So basically, we're talking about isosceles triangles that are also right triangles, which means that these angles are both 45 degrees, right? We can all agree on that. And then here I've got the same 45, 45, 90. Let's get rid of you. And the legs are the same. And the hypotenuse is a different number, right? But what we're going to look for is some patterns with that third number. So what I'd like for you to do, if you're on the Google Slides in today's assignment, you can go to the Desmo link yourself. If you are in the Pear Deck, we're going to do the Desmo link together. So what I'm going to ask you to do is write down some side lengths for these triangles. So we've got 2.35 and 2.35 and 3.34. So on a scratch piece of paper, write down 2.35, 2.35, and then 3.34. If you're doing this yourself, you can move the triangle. You've got to try to make sure it stays a 90-degree angle. Remember, it only works with 90-degree angles. And I'm going to try to make it go out all the way to a 3 and try to get it exactly 3. Oh, it doesn't want to get exactly 3. We'll do 3.31. So 3.01, 3.01, and 4.24. So all we're doing is playing with this Desmo activity. So it's linked in the Pear Deck or in the Google Slides, but you can't click on it in the Pear Deck. So all we're doing is playing with this. We're trying to make an isosceles triangle that's right. So I've got my 4 and my 4 to make it isosceles, but I've got to make that a little bit bigger to make it 90. And then I lose my 4. It's really maddening to try to make it exact. My mouse pad is not, oh, there it goes. So we've got, so I want you to write down 3 or 4 examples. So I've got 4, 4, and 5.66. 4, 4, and 5.66. Okay. Now that we've played with that a little bit, and the Desmo link is right here if you just joined us, we've got two 45-degree angles, and the sides opposite those 45-degree angles are the two isosceles legs. So we can put into our chart 1, 1, and 1.42 because we're already given that in the 1 radius circle. And we can put in 2, 2, and 2.83. I want you to put these into your slides. And then we can use some of the ones that we got. So what were some of the numbers that you guys wrote down? Four, 4, and 5.66. And what was another set of numbers? We did a 3.01. Did anybody write down that one? 4.24. Anybody write down one more? We can go find another one. Let's try to do 5. Maybe. Why is it not moving? Oh, there we go. So 5, 5, and 7.1. 5, 5, and 7.01. Was it 01 or 1? 7.1. Now we're going to do something in the calculator. We're going to take the opposite side, the 45, and divide it by the hypotenuse, the 1.43. So what's 1 divided by 1.42? 1 divided by 1.42 gives me 0.7. I love it. What about 2 divided by 2.83? What about 4 divided by 5.6? There's a bug flying around my head. It's making me crazy. 0.7, so 0.71. I need my brother. He's like a fly ninja. 3, what's my next question going to be? And what do you got? About the last one? There's a pattern here. The small side is 0.7 of the hypotenuse. Do one last thing in your calculator. Do the square root of 2. Square root of 2. 1.4. That's twice as big, right? 1.4. Square root of 2 is going to be our hidden gem here. So if you go to slide 4, you can draw yourself a little isosceles triangle if you want. So we've got a 45, and a 90. The two sides have to be the same. And the third side is going to be whatever that number is times the square root of 2. That's where that 0.7 comes in. Okay, so all we're doing is finding a new pattern, and this should be a shortcut for some trig problems. You can always use trig and inverse trig. You can always use Pythagorean theorem. But if I know this is a 45-degree angle, then what's the side that I have labeled x? 8. No math involved, right? And if I know that my hypotenuse is always that side length times the square root of 2, how can I find y? That's it. What is 8 times the square root of 2 as a decimal? 11.3. So again, in number 2, I've got that 45-degree angle, which means my other angle is 45 degrees. That means it's isosceles. So which side is also 25? It's like math without doing math. Just because you know the ratios and the patterns. So as long as those corners are 45, then the sides opposite them are going to be the same because they are isosceles right triangles. Okay. How do I find x? How do I find the hypotenuse, the side opposite the right angle? What's the relationship there? Also, x on the square root of 2. So don't get confused by the variable. What I'm looking for is that side length, that leg, times the square root of 2. So 25 square root of 2. What's that in the calculator? Okay, 35.4. So if you're just joining us and you're not sure where we are, today is the 19th, right? 11/19. So if you go into the folder today, into today's folder, you'll see a link to patterns of special right triangles. We also have a Pear Deck running. So if you'd rather have the Pear Deck, the link is here. So the third problem changes it a little bit. Because here I know my sides are the same. So they're going to be the same. And my hypotenuse is going to be different. The hypotenuse is that bigger side. So I've got to do x on the square root of 2 equals 19. Okay, so I just put my 3 things in, x, and x on the square root of 2. I already had a 19 that was given to me. It's kind of like in trig where I know the O or the H or the whatever. You just have to set up that equation and then solve it. So anybody have an idea of how you would solve that equation with a radical in it? What if I gave you this equation? How would you solve that? You divide by 2. We do the exact same thing over here. We divide by the square root of 2. The square root of 2 is just a decimal. It's just a fancy way of writing that decimal. So you're going to do in your calculator 19 divided by the square root of 2. And depending on what kind of calculator you use, you have to do it a little bit differently. So in the Desmo, you're going to do 19 divided by, and then you can either come down here and click on the button that says square root, or you can do SQRT, square root of 2. If you have a handheld calculator like this, you've just got to put in 19 divided by square root of 2. So it looks like that, right? 19 divided by the square root of 2. If you're using your phone, you've got to do, whoa, that was crazy. Anybody ever drop the phone on their face? Yeah. 19 divided by the square root of 2. Okay. I have an Android phone. If you have an Apple phone and you're using that calculator, then it looks a little bit different. I think you have to do 19 divided by 2 and then square root. It's like that iPhone, I don't use it, so I don't know how to program that one. So what do we get for an answer when we did that? 13.4. So both of those x's are 13.4. 13.4, which means for our answer down here, I'm going to erase some of this so it looks a little neater. 13.4 and 13.4. Because those are the legs. The x and the y that they're asking for are the legs of the triangle. Okay, so it's just a pattern. It takes a while, just like trig did, to kind of gel in your head. You're probably going to leave today still confused, and that's okay. You guys have just accepted it at this point, though, right? Just kind of going with it. No, you should not. So smart. So what side do I know? What's the easiest one to find? X. What's X? 13. See, smarties? So if my two sides are 13, what's my hypotenuse? 13 times the square root of 2. I've got two sides that are the same. So I do 13 square root of 2. And that makes perfect sense because 18 is bigger than 13, and I know the hypotenuse has to be biggest, right? So over here is where it gets a little kooky. Here, I've got my two sides that should be the same, so x is going to equal y. And then I've got my hypotenuse that's this x on the square root of 2. This is where I have to do an equation. So this is my equation. X square root of 2 equals 30. So I've got to divide by the square root of 2 and divide by the square root of 2. Those cancel out, and x equals what? Should be something smaller than 30. Anybody else get 21.2? 30 divided by the square root of 2. Okay, and is that both legs? It is. Yeah. Like in Desmos? I might not be understanding what you mean exactly, but if you put in that equation, x square root of 2 equals 30, x square root of 2 equals 30, and then you zoom out, that's your answer, 21.2. I don't really like doing that. Where am I? This is where I am. 21.2. So that is your answer. It's where the x-intercept is. But a lot of places you're not allowed to use Desmos. I know we use Desmos a lot, and Desmos is a great tool, but when you start doing stuff like that, it'll give you some bad habits. Yeah, it absolutely works, 100%. So what do I do for number 3? Is the 3 the y? This is kind of a trick question. Oh, no. It's not isosceles. How do you know it's not isosceles? One is for sure longer than the other. This one is not going to work because it's not a 45, 45, 90 triangle. Okay, so these only work with 45, 45, 90, where you have an isosceles triangle and those two legs are exactly the same. So let's leave slide 5 and go to slide 6 and look at a new little app. So here I've got 30, 60, 90 triangles. In the little one, it's hard to see, but 30, 60, 90 triangles. So in my table, I'm going to do the small side, which is 1, and the medium side, which is 1.74, and the large side, which is 2.01. That's my small triangle, the 1, 1.74, and 2.01. And then I'm going to go down to my medium triangle, and I'm going to do 2. And the next one is 3.47, and the large one is 4.01. Okay, so I've got small, medium, and large, and small, medium, and large. The small is always opposite the small angle. The medium is always opposite the medium angle, and the large is always opposite the large angle. So the hypotenuse is always biggest because the 90 is always biggest. So let's go to this Desmo link and see what we notice. So I'm going to play with a triangle, and you tell me when you see a pattern. I'm going to move this down here a little bit. And the angles have to stay the same. You have to have a 60 and a 30. So if I make this a 2, what do you notice? What if I make this 2.5? Can I make it exactly 2.5? I need a better mouse. So what happens here? There are 2 5s. What if I make it a 3? They're all going to stay the same, the 30, 60, and 90 for sure. What if I make it 3.1? The angles stay the same. What happens to the sides? They do. What's the relationship between the small side and the long side? The small side and the hypotenuse? Does that work every single time? It's pretty close, right? Desmos is rounding because it's not exactly accurate. So if I go to 4, and go to 4.5, the small side is always half of the hypotenuse, or the hypotenuse is always double the small side. So opposite the 30 degree, that side is always going to be half of the hypotenuse in this 30, 60, 90 triangle. So let's write down some of these too. We'll write down 4.5 and 7.79 and 9. And we'll come down here and we'll try to get a 4. So we can do 4 and 6.93 and 8. And let's get a 3.5, maybe. 3.5, 6.07, and 7.01. So now let's go fill in our table and see what we've got. So we had a 3. No, we didn't. We had a 3.5 and a 6.07 and a 7.01. So you're filling in your table while I'm filling in mine. We got a 4, a 6.93, and an 8. And then 4.5 and 7.79 and 9. So we kind of already established that the small side is half as big as the large side, right? Oh my goodness. So what's the large side divided by the small side? 2 divided by 1 is 2. What's 4.01 divided by 2? What do I put in this box? What's the large side divided by the small side? So 4.01 divided by 2. 2.005. And then what's 7.01 divided by 3.5? 5 again. And then what's 8 divided by 4? Still 2. And 9 divided by 4.5. So there's a ratio. This 30-degree side, the side opposite the 30-degree, is always going to be half as big as the hypotenuse. Just like we found the ratio to be 0.7 in the isosceles triangles, in these scalene triangles, we're going to find a ratio 2. So what's the medium side divided by the small side? 1.74 divided by 1 is going to be 1.74. But what's 3.47 divided by 2? 3.47 divided by 2. 735. So it's very close to 1.74. What is 6.7 divided by 3.5? 1.9. 1.7 divided by 3.5? 6.07 divided by 3.5. We gotta have an O in there. Awesome. And then last one, what do we got? Do we get 1.73 again? Okay. And 7.79 divided by 4.5? Do the square root of 3 in your calculator. What do you get? So the pattern here is going to have the small side be half as big as the big side. And then we're going to have to multiply by the square root of 3 instead of the square root of 2 because we've got 3 different side lengths. It's a scalene triangle. We're going to do square root of 3. So let's go look at slide 7 and see if we can make sense of this. Okay. Opposite the 30 is the x. Opposite the 90 is the 2x. It's twice as big. And then you multiply that small side by the square root of 3 to get the side opposite the 60. So if I label my triangle, this is the small side. This is the biggest side. And this is the medium side. So if the small side equals 5, which side equals 10? Which one? The hypotenuse. If opposite the 30 degrees is the x, that's 5, right? Come on. Then opposite the 90 is going to be 10. And then opposite the 60 is just going to be 5 on the square root of 3. So what is 5 on the square root of 3 as a decimal? 8.7. Same thing in the next one. I'm given the small side, right? So the small side is 14. So what do I know about the hypotenuse? Absolutely. 14 times 2 is 28. And then I just stick 14 and the square root of 3 together. And what do I do? What do I get when I do that math? 14 times the square root of 3. 24.6. Do we agree? Oh, 0.2. So let's see about the last one. So here I'm given the hypotenuse. So is it easier to find the short side or the medium side from the hypotenuse? The short side. All you got to do is divide by 2. So what's 32 divided by 2? It is for sure 16. And that's the side opposite the 30. Which means that the side opposite the 60 is just that number times the square root of 3. Awesome. So again, this is the last set of patterns for right triangles. You'll use these a lot when you get to math analysis. If you ever become a rigger and do a lot of work with cranes, you would use these a lot, and you'll see them a lot on the SAT. I don't know whether the SAT is going to be important as we go through this whole Corona thing. You guys might be able to skip out of having that be an important thing in your life. Otherwise, these are not that important. So if you're not going to be, if you're not going to run a crane, and you're not going to go to math analysis, and you're not going to take the SAT, then these are not going to be important. But if you're going to do any of those 3 things, you really do need to know these special right triangles. Okay. So I know a lot of people are like, why do I need to know this? So that's why, those 3 reasons. I can't think of any other reasons why you would need to know this. But we still need to learn it. So where do I put the 46? What is that? Is that the x, the 2x, or the x on the square root of 3? That's the 2x. So what's x going to be? Well, in our case, y. Yep, this short side, 23. And then that medium side is going to be 23 on the square root of 3. 39.8. Is it starting to make some sense? Good. So where do I put the 20 in my chart? What do I know about that? It is. And this is the one where you have to build an equation. So I'm given 2 things. I have to set those equal to each other. So x on the square root of 3 equals 20. We're going to solve that. Remember, you solve by getting the x by itself. So you're going to divide by the square root of 3. So in the calculator, what is 20 divided by the square root of 3? Excellent. So the y in this case is 11.5. So what's my hypotenuse? Beautiful. Some people like drawing it on the triangle, and some people like this little hashtag like set of boxes I've got up here in the corner. You just kind of have to figure out your favorite way. So if we go to that last problem, what can I fill into my chart? Oh, and this should be a 30 and a 60. I just noticed that. I can fill in that 9 and the square root of 3. What angle is that opposite? The 60. So I'm going to do 9 on the square root of 3. And I'm going to set those equal to each other. This looks like a monster problem, but it actually is going to turn out to be super easy. So if x times the square root of 3 equals 9 times the square root of 3, I solve that by dividing by the square root of 3, right? And if I multiply by a number and I divide by the same number, don't they cross out? Yeah. So which side is 9, x or y? Perfect. Which means y is what? Somebody say 18? Any questions on slide 8? Okay. Now we're going to get some pictures. We're going to try to put this into application in real life. Remember I said that a lot of cranes use these, right? So there's stress on cranes, and if you're running a crane or you're an engineer of some sort, you have to know how much stress the crane can take. So this top angle can't be more than 30 degrees, which means this bottom angle has to be somewhere close to 60 degrees, right? What are the possible lengths of the triangle if the center cable, that vertical cable, is 6? So if I make my table, I've got the 30, the 60, and the 90, right? And that was x on the square root of 3, and 2x. So where do I put the 6? It is. So that goes here, which means I've got to set that up in an equation. And I know that's hard to read. Let me write it over here. X square root of 3 equals 6. So how do I solve that? Brilliant. Divided by the square root of 3. They cancel out over here on the left. So x equals. So if I know the bottom of that is 3.5, what's the hypotenuse? 7. And then it says, it's probably too hard to read, estimate the diameter of the barrel. Is it times 3 or times 2? If this is the radius, exactly, yeah. So the diameter is going to be 7? Just 7. The radius is 3.5, and the diameter is going to be 7. I feel like you guys are picking this up really fast. I'm so impressed. Let's look at slide 10. Base angle cannot be more than 60 degrees. So we're going to make this 60. Oh, you did. Okay, hold on. Relax. There was some serious urgency in that. Yeah. You got it, Ela? What is the answer? We good? Okay. So here it says that base angle can't be more than 60 degrees, which means this top angle, oops, is going to be our 30. And our right angle is down here. So what are the possible side lengths of the triangle if the horizontal distance is 30? Where's the horizontal distance? Is that up and down or right and left? Okay, so we've got 30 feet here. And if we make our little chart, 30, 60, 90, x, 2x, x, square root of 3, where does that 30 feet go? The 30 feet is the x because it's opposite the 30 degrees. So what's the easiest thing to find? So what's the hypotenuse? 60. So that's a 60-foot boom on the crane. And then what's this vertical distance? Times the square root of 3. So because I know the x, I just substitute that in there. So what is 30 times the square root of 3? 1.9. Or we could say about 52. This is really close to a Pythagorean triple. 30, 60, and 52. Super close to a Pythagorean triple. Bless you. Okay, on slide 11, we have two triangles. They're both equilateral. I can. Sterling, you got it? So on this one, they're both equilateral. So we're going to talk about the red triangle first. Okay. So if I know they're equilateral, I know 60 and 60. And then this has been cut. So what are each of those top angles if it was 60 before it was sliced in half? 30 on one side and 30 on the other side, right? So if we just look at one of those, we know that's our 30, 60, 90 triangle, right? What are the possible side lengths of the triangle if the box is 20 feet wide? So if we know this is 20 feet wide and it looks like the triangle goes the whole length of it, then this whole thing is 20. I mean, 40, because this is 40 and 20 and 15, right? 20, 15, and 40. So this half is 20, and this half is 20, and this side is 40, and this side is 40. What I'm looking for is this height. So what can I put in my hashtag here? 30, 60, 90, x, 2x, x on the square root of 3. Where do I put the 20 and where do I put the 40? I know my drawing got a little crazy. This side here is 20. What's it opposite? What makes sense if I know that I've got two sides, one is small and one is big? Where do I put the 20 and where do I put the 40? So the smaller side is 20 and the bigger side is 40. So how do I find that height? Times what by the square root of 3? The 20 or the 40? The 20. Yeah. So what is 20 times the square root of 3? 34.6 is the height of that red triangle. Okay, 34.6. And I know it's like super tiny. What are the possible lengths of the pink equilateral triangle if the height of the triangle equals the height of the box? So the height of the box was 15. So the height here is 15. And I want to know the side lengths. So 2x and x. So I still have my 30, 60, 90. I still have my x, my 2x, and my x on the square root of 3. There's some serious lag on my computer today. Where do I put the 15? Is that the x? It would. So this tall side is opposite a 60-degree angle, so it has to go there. So we've got to set this equation up. 15 equals x on the square root of 3. And how do I solve that? The square roots of 3 cancel out. And what is 15 divided by the square root of 3? 8.7? I love it. So the short side is 8.7. So what's the whole length? If x equals, like this piece here is 8.7, what's the whole side of the triangle? Love it. That's the hypotenuse. So if this is an equilateral triangle, all 3 of those sides are going to be 17.4. The x is just half of it. Okay, and that's the hardest part about getting these questions. These are tough. I'm definitely pushing you here. So if you're confused, it is 100% okay. Did everybody get slide 11? Can I go slide 12? That's all I'm going to write on it. So if you're screen capturing, you can do that. I'm also making a video, so I'll upload the video as soon as class is over. I don't know if anybody goes back and looks at those. So slide 12. I'm going to blow this up a little bit because I'm tired of writing small. That was a little too big. There we go. That's a little better. So I've got the smallest angles have to be 30, which means I've got a right angle and then a medium angle of 60. And I've got a 30-degree angle and a right angle and a medium angle of 60. What is the ratio of the smallest side to the largest side? So we can make ratios in a couple of different ways. We can do small to large with a colon, or we can do small to large with a fraction, right? And we can kind of label these. We know opposite the 30 is x, and opposite the right angle is 2x. and opposite the 60 is x on the square root of 3. Same thing over here. 30 is going to be opposite some number. And then opposite the right angle is going to be twice that big. And then opposite the 60 degree is going to be x on the square root of 3. Those are similar triangles, so the ratio is going to be the same, even though the numbers are going to be different. If I take the small angle, or the small side, that's x. And I take the large side, that's 2x. If I have an x in the numerator and an x in the denominator, don't they cancel out? Yeah. So that ratio is small to large is exactly what we found after we looked at the Desmo activity. The small is always going to be half as big as the large, or the large is always going to be twice as big as the small in a 30, 60, 90 scalene triangle. So let's add some numbers in here. What if you know that the crane booms are 50 feet and 30 feet? So the boom is this physical part. So this equals 50 and this equals 30. So what other information can I fill in? X. What's the x in my small triangle? 15. And what's the x in my big triangle? 25. It's half as big. So if I know 50, I know 25. If I know 30, I know 15. Then I can just take that x, that 15, and replace it right here. So this is going to be 15 square root of 3. That's the height, right? And I take that 25, that x, and I substitute it right in here. And that's 25 square root of 3. That's the height here. And you can definitely put those in the calculator and find the decimals, but I don't know that we need to do that right now. But kind of those are the patterns. Again, across from the 30 is the x, across from the 60 is the x on the square root of 3, and across from the right angle is the 2x. Everybody got that slide? Last one. So this is real deal here in Hampton Roads. Anybody ever notice the giant blue crane up in Newport News off to the left as you're going up towards Williamsburg? Yeah. Does he? Yeah. So Newport News, does he help build aircraft carriers or does he help build submarines? He mostly works on repairing ships, but he builds it from time to time. Okay. Cool. So up where that big blue crane is, they build all of the aircraft carriers for the United States Navy, and they build half of the submarines. So they build about one aircraft carrier every 3 to 4 years, and they build like maybe 2 or 3 subs in that same time frame. This used to be one of the biggest cranes in the world. Now there are much bigger cranes in Asia. But this is an equilateral triangle that is 230 feet tall. 230 feet tall. This is the bow of an aircraft carrier that they're putting in. It's huge. So our question is, what is the hypotenuse? And what is this length down here? How can I figure that out if I know that it's an equilateral triangle? They are, because it's an equilateral triangle. This is 60, that's 60, and then these are cut in half, so that's 30, and that's 30. So I can redraw my triangle if that helps. Let me erase it and make it a color that actually shows up on that sky. Sometimes if you have a weird perspective, it definitely helps to redraw it. And I know this is 230. I can also make my hashtag if you like that. Some people like this and some people don't. You just got to figure out what your method is. X, 2x, and x on the square root of 3. Where do I put the 230? And what's the next step? Divide. So we set these equal to each other. X on the square root of 3 equals 230. So we definitely divide by the square root of 3. And what do we get? So this side down here is 132.8, which means this x here is 132.8. So what's the long side? $265.6. So if you think about it, our football field, right, yesterday was how long? About, right? So the length of this side of the triangle is almost a football field long. That is crazy, isn't it? But that is special right triangles and trig, ladies and gentlemen, and that is the end of our lesson for today. So what I'm hoping you come away with are these ratios, right? We are gonna, ooh, that went crazy. We are gonna start with our catapults tomorrow. Okay, so I'm gonna stop sharing so I can talk to you. We're going to start with our catapults tomorrow. So if you want to Google YouTube videos on catapults, feel free to do that and do some research. I really am excited and hopeful that some people will go beyond the scope of what I put in those materials bags and make some really cool catapults. Elias told me maybe he already has one from another year of school, another project. If you make a really good one, well, actually, even if you just make a popsicle stick one, it's going to be cool. I'm going to ask you to make a video of it. And that's going to be your homework for the weekend too, is to finish up your catapult and make one. Okay. And then next week we will come and finish up this triangle unit before Thanksgiving. But that's all I've got for today. You guys are welcome to go if you want. And I'll see you tomorrow. Bye.